as Benny already said, please unmute yourself in case of any questions or use the chat window. In case of the chat window, Benny will read your question because I am currently on vacation, so I only have one screen and I cannot watch the chat window. Other than that, welcome to data modeling in Power BI, as I think is an underestimated task. It's very important to have your data model in the right way, otherwise your Power BI report will suffer either only performance or will show wrong numbers, and neither is very good for your reports and for your peers. My name is Markus, and I work with models. And sometimes if I tell people that I work with models, some think about beautiful people or beautiful scenes or whatever. But it's on the other side, it's with data models, like we can see in Power BI. So it's tables and there's relations and foreign keys and whatever. And that is what we will talk about in the upcoming 60 minutes. So Power BI Desktop. Power BI Desktop is born as a self-service BI tool, business intelligence tool, which is really good because it makes things very easy. And it tries sometimes to do guesses, educated guesses, to make it comfortable to use for you. So even if you don't know anything about data models, Power BI will try to come up with a data model and build things for you. But in some cases, this could be not so good because these educated guesses might be wrong. So you have either the potential for improvements, or these cases could be so wrong that you end up with the wrong performance or the wrong numbers in your report. So good data model is really crucial and really important. And you should think of the data model you're building in Power BI. So for this agenda, I will talk about relationships. So this is really an introduction. What is relationships? What attributes are available there? Then I will also talking about denormalizing data models. If you're working with databases, if you have a computer science degree or something like that, you should be aware of denormalizing and what a normalized schema is. If not, I will introduce you to that in the second section of my talk. Then we will take a look on the date dimension, because in almost every data model I see there's some connection to a time or to dates. So it's a very important dimension in most of the models, because almost all models are connected to dates. And then we will see how much time there is. I've prepared two use cases to show you like what is the outcome. So this is more advanced level than at the very end of this talk. We'll see how much time we can spend there. Is there a question? Somebody unmuted yourself? No. So start with relationships. What is relationship? A relationship is in Power BI is like a foreign key constraint in the database. So if you are into databases, you have tables, and those tables have relationships, and those relationships are persisted in the data model as foreign key constraints. And this is a constraint. So in the database, the foreign key constraint assures that you cannot insert a row into the sales table with a customer key, which is not available in the customer table. This is what a constraint does. In Power BI, the relationship looks like a constraint, but it is not a constraint. It is a filter propagation. So it's not avoiding inserts or doing anything when you load your data. It does something when we use the data, when we build up reports and dashboards. So the relationship is then propagating the filter from one table to the other one. If I select a certain customer, this filter propagation will make sure that I only see the sales for this selected customer. So it's going the other way around. It's not doing something at the sales table like avoiding inserts, but it's propagating a filter from the customer table to the sales table. As an attribute, we have two attributes at relationship level. One is the cross filter direction. So the cross filter direction can be either single, so it's only the customer table is only filtering the sales table, or I can enforce that also the sales table is filtering the customer table. This sounds interesting or attracting to some people, but usually you should avoid the both relationship, and we will see this in the use case at the very end of this talk, why this is the case. And the other thing is the cardinality. So the relationship between the tables can be either that I have a one-to-many relationship, so one customer can potentially have several sales we're hoping for that we're not selling just once to a customer, but that the customer buys products and services several times. So with this one customer, potentially many sales. The other one would be a one-to-one relationship, which is really rare. And usually I would try to put everything into one single table instead of having a one-to-one relationship. And since I can't remember since which version, we also have the many-to-many relationship available. And this is not the classical many-to-many relationship like we know from databases where you normalize your table, your model and your relationships. But this is like I have many on one and also many on the other one, and they can filter themselves on this level. Again, this is also something like the both cross-filter direction. You should try to avoid as much as possible because it increases the complexity of your model, and it will certainly slow down your reports and your analysis. And again, it might be attractive to have this many-to-many relationship because you want to join something, it's not working as a one-to-many, and then you just do it as a many-to-many because this works always, but usually that's not the good approach and not the best approach to do. And when I say one-to-many, one means 0 or 1. So like, yeah, maybe one not that much, but the many could be 0, 1, or many. So one customer could have many sales. If the customer is very new, we just created the customer and he didn't buy anything so far, there would be 0. Or he started to buy the first product or service, then it would be 1 sales per customer. But still, there's a potential for having many sales for one customer. We still call this a one-to-many relationship. So the many side can be 0, 1, or many. Let's see this in a demo. So let's start the first demo. That would be the relationships. So I've got here Power BI. We don't need this. And let's start with the model view. So in the model view, we see how the relationships can be. And we have one relationship could be, for example, on a one-to-many relationship. So there's one account. And for this account, we can have potentially many relationships. We can see both attributes here. So we have the 1 here and the star here. So that means one account can have many transactions. So the star stands for many. And the cross-filter direction is single. So this triangle means that the pointy end of the triangle is pointing towards the transaction. So the account table is filtering the transaction table. So not in both directions, but it's only a single direction. We can always change this by double-click on the relationship, and then we can zoom in here a little bit. So we have the transaction table, we have the account table, we see the first 3 rows, and they're connected with the account ID row. And then we see the cardinality is a many-to-one. That means many transactions can be assigned to one account. And the cross-filter direction is single. And this relationship is also active. We'll see later what the activity or why there would be potential to have a relationship there which is not active. Why does this make sense? We will see in a later demo. So let's zoom out here a little bit again, and then we're going to the report. So we currently see that there's account table with 4 entries. So we have 4 accounts, Bill, Jeff, and Marcus. And then we have the transactions on those accounts. And we can see if I select one of the accounts, so for example, Bill, this account table will filter the transaction table, and we only see the transactions for account 11. Or if I change to Jeff, or Bill and Jeff, or Marcus, we can see this is always filtering in this direction. If I click on this table, you will see that there's nothing happening on the account table because the filter direction, the cross-filter direction, is only going from account to transactions, but not the other way around. This is very important to see. You can see this here. You might think, Marcus, doesn't make sense what you're telling me, because if I click on the account ID, I can see that there's a filtering happening up there in the report with the account and amount. And this is a different thing. So when I say it's not filtering the account table, I was talking about what's happening in the relationship in the data model. But the Power BI has not only the model, but it's also reports. And on reports, we have visuals. And by default, the visuals are cross-filtering each other. So if I select something in one visual, it's filtering the other visual. I turn this off for the account table, but I let the default here for the report, for this report table up there. So when I click here, it's filtering this visual up there, not because it's in the model, but it's because there's a filter happening, a cross filter happening also in the reports. Again, Power BI is a self-service BI tool, tries to make everything comfortable, but sometimes it's confusing and sometimes it's not clear to see why things are working like they are. And you can always turn this cross filter in the visuals off by having the edit data action. So we can click here on the transaction, and then I can turn off the filtering to this table by setting this to none. This is how we can change this. So there's different things happening in Power BI. The next thing on the model side, we could have a one-to-one relationship. So we have like the customer detail in the customer, and there's exactly 1 or 0 rows. It could be that we have a customer without any details, so this one could also be 0. Maybe we could also have a customer detail without a customer. That would also be possible. But usually I would avoid a model like this, but put everything together in one single customer dimension for 2 reasons. Because the model is more complex with having 2 elements in our model here. And it's only 2, but this could be part of a bigger model. And the second thing is that every table we have in our model shows up in the field list as a folder. And the more tables we have, the more folders we have, and the more confusing it's for our end users. So they have to remember, can I find the description in the customer detail, or do I find it in the customer? So they have to look up 2 folders if they can't remember where it is. So I would put this in one single table if it's possible. The only reason I see to having this one-to-one relationship would be if the data source for the customer and the customer detail would be 2 different data sources. So 2 different databases or files or whatever. And if I want to refresh those tables on different schedules, then potentially we could have this in 2 different tables. And with the same in the report, I think you just believe me there. And then there's this many-to-many relationship between the account customer and the transaction. So we have like the account is on the one side, and the account can filter. There's a filter direction into the direction of the account customer, and the account will also filter the transaction table. But the transaction table does not filter the account table, and it's not, as it is not filtering the account table, it cannot also not filter in the account customer. And it's also true for the other way around. So if I have some selection, some filter applied to account customer, they will not be applied to the account because the filter direction is only going in one direction. And we can see this in the report. So let's go to the one-to-many-to-one relationship. So if I select something like bill here on the account, it will filter the transaction and the account customer table. But if I select something here, it will not have any effect on the account and on the nor on the transaction and the other way around. If there's any questions, please just interrupt me. If not, then we are going to...
Yeah. So far, no questions, actually, Markus. So everything's going good.
Yeah, either I explained everything very good, or it was so confusing that nobody dares to ask a question. Always 2 possibilities. So let's take a look on denormalizing. So denormalizing or normalizing starts with the following thing. So if you think about, if you, for example, ask me about giving
sorry to interrupt, but I do have a question.
Yeah, very good. Please come up with the question.
You've muted yourself, Hans, so you can ask the question.
Okay, actually, so yeah, okay. Can you go back to the place where you showed the tables just before?
This one?
Yes, this one. Yes. So if here you select 11 in account, the first account number there, it has no effect on yeah. This is in the customer. Eh? Here you says here you select account 11, but if you do it in the other column, it has no effect on there. I don't really understand how this is possible. Why this has no effect? And can you make this effect work or not? Is it possible if you select the 11 there, that it only, let's say in the second table, it only shows the 11? Is it possible or not?
You mean here in the account customer or in the account table?
Yeah. If you select there, Yes, if there you select this one, can it have an effect on the account table?
Yes, it can. Of course, I cannot change it here because it's just a visual showing you the model. We have to go there, and then you just change the filter direction here. So we can change this to make this both. If I do this, and we see this like this triangle is now going in both directions. So there's a pointy end in both directions. Therefore, now going back to the report and I select something here. So I've selected 11. It's selecting the account table.
Okay.
And as the account table is also have a cross filter to the transaction, it's going to filter the transaction table.
Yeah.
I can also do this with the other ones.
Yeah, but this has a certain risk, you told.
Yes. And we will see this at the very end.
Okay.
Because I think it's hard to explain, because you might think it's a good thing to have the possibility to select any place, and then the filter is going to the other tables. That's what I hear from my customers. They like this possibility to have the possibility to filter anything, and this filter will then propagate it through the whole model to filter everything else. Like this will also, like what we have now, would also be useful if you have slicers. So if I select something here in the account customer, I do not want to see transactions for other accounts, because if I select in the slicer the transaction for another account, I will end up with nothing, because there's no value in the account table with account customer 13 and account customer 12. This would not work. So people like this idea of having this filter propagation. As we will see at the end, I hope I do not talk too long, so I can show you this at the end for the use cases, that you will end up somehow with a possibility where you not can set this to both anymore, because Power BI forces you to have only one way from one table to all the other tables. And the more you have, the more tables you have, and the more relationships you have on both, the higher the probability that you end up in your complex model with two potential paths. So like one path is going through the account to the transaction, and another is going through another table to the transaction. And then Power BI says, I do not allow you to send this new path also to both, because then I, as Power BI, do not know, do you want me filter the transaction table over the account table, or do you want to select filter it over the other table? So it would not, Power BI will not allow you to create this. And then you have the problem that you cannot add this anymore, and that you have to find another solution for what you want to achieve. And in my opinion, you should start with the right solution, avoiding the both relationship at first hand. And there's a solution in DAX. So we can either have, and this is like the single sentence outcome of my session is either you have complexity in the model and very easy DAX, or you have an easy model, not very complex model, but more complex DAX. You can always interchange complexity between the model and DAX. And there are things which you should do in the model, and there are other things you should do in DAX, generally speaking. Of course, there's always exceptions. Did I answer your question?
Yes, you did.
Very good, very good. And thank you for your question, because I think you should use the chance of asking a question, because of course you can always watch videos on YouTube, and you can watch this recording on YouTube, but you cannot ask questions there. So please use a chance to ask questions here, as this is an interactive webinar. So let's go to denormalizing. So denormalizing starts with the idea that if you ask me that I should give you a list of products and their sales and their assignments to subcategories and categories, I most probably would give you a report or a file or whatever, one single thing. So I would give you one single table with 4 columns. One would be the product, the other would be the subcategory, the third would be the category, and the last and fourth would be the sales amount. That's the easiest, the naive way of storing data in one single table. And you see this most often also in Excel. There's one single table, there's maybe other worksheets, but the other worksheets are storing different things. So one single table would be the easiest way to understand, and the easiest way to query, and the easiest way to create. The one problem we're having with the single table approach is redundancy. So there's like, if I have a product category with more than one product, the name of the product category would be repeated in my table several times. And this is a bad thing. This is a bad thing for once, because we're storing this multiple times, so it's taking more space. And the second thing is we're having troubles when we want to change or insert or delete things, because when I want to change the name of the product category, I have to make sure that I change the name on every single occasion. For example, bike to bikes. If I do not succeed in having all those occasions, then I will end up with technically two different product categories. So some products would be in bikes, plural, and other products would stay in bike, singular. So we would have a report with 2 lines, bikes and bike. This is a bad thing. The other thing is if we want to insert things. So if I want to insert into a new product category where I do not have a product currently, then what should I do in my table? Like, do I leave the product name empty? This would be a solution. But how do you know that I have to insert this with an empty row? That's complex. And the last thing is if I want to delete things. So if I delete the last product of a product category, I have to be aware that I'm not allowed to delete the last line. I have to set the product name then empty. So this is more complex in handling things. So usually we try to avoid a single table approach. This is good for collecting data or giving data as a report to other people. But if you want to work with data in a more professional way, then we should avoid a single table approach. So what people do who are writing applications, they aim for normalized schemas. So normalized schema, the idea of a normalized schema is to avoid redundancy. So we'll hear this is like the 3NF would be the third normal form, or the BCNF, the boycott normal form. I think there's also a 4th, 5th, and 6th normal form. Usually, if you're in 3rd or boycott normal form, you are happy as an application developer in your database. And the idea is to avoid redundancy. How can you avoid redundancy? By splitting the things up. So the single table with the 4 columns, you would have one table with the sales and one key referring to the product table. So one table is the sales. The second table is the product table. In the product table, you would have the key of the product and the product name and the key to the subcategory table. So the third table is the subcategory table. And there you have, again, a key for the subcategory, the name and the attributes of the subcategory, and a foreign key referring to the product category table. And there you have the same, the key for the product category and all the attributes there. So we have a really complex schema out of this one table. We suddenly end up with 4 different tables. And this is just for this easy approach. And you can imagine if your application is more complex than having just products and categories and sales, you will end up with a really complex data model. And this is what you do if you're writing applications. You're aiming for a redundancy-free data model, which is really, really good because we do not repeat things. So we just, if I want to change bike to bikes or the other way around, it's just one single row in one single table. This is easy to do. There's no chance of any error because either I do it or not, but it cannot end up with 2 different categories, bike and bikes. Also with the insert, update, and delete, this is really easy in this model. The only backstory of this complex schema is really, really bad for reporting. So for business intelligence, for data warehouses, for us as Power BI users, I do not want to have to query a complex model like that. I want to make this easier for me. And the easier way is not going back to the single table approach, but there's like a compromise. The compromise is the denormalized schema, where we have some redundancy reintroduced, but not all. And the thing is that we're trying to find out what are our fact tables. Fact tables are those tables, as we will see, with all the numbers, and dimensions are the other tables. The dimension tables are those where we filter and grouping on. And what we're aiming for is a star schema. Maybe in some cases, Snowflake schema would also be nice, but we're aiming for a star schema with fact and dimensions. So what is this? Let's see here. Again, single table. I think this is easy to think. This is only one. I mean, this is one thing in Power BI. The model view, you have only one single table. There's no relationships. There's nothing can go wrong with both or single or one-to-many. You don't have to think about that. But that's not the best approach. The better approach is the star schema, where we distinguish between dimension tables and fact tables. And dimensions store everything on how did something happened, what happened, when did it happen, where did it happen, who made this, and why did it happen. So those questions are answered by the dimensions. We're using these attributes to filter. So we want to know in which year did this happen, who did buy the product, what product was sold, or to group to get a list of like our product categories. So we say sales per product category. Those tables are typically relatively small. So like hundreds, thousands, tens of thousands, maybe it's hitting 1 million if it's customers and you're using, you have end users, then it can be bigger, but compared to our fact tables, it's still relatively small. And those tables are always on the one side. So I want to filter a year or a date or a product or a territory or an employee. And I want this filter to be applied on my fact table to see only the sales for this employee, for this year, whatever. These tables consist of a primary key. So something I can identify a row with. That's called a primary key. And all the attributes. So, and I don't care how many attributes and how big the attributes, because this table is rather small, several thousand of rows. Or if you think about a calendar, a date dimension with 1 row per calendar day, we have less than 400 rows a year. So if we store 10 years, it's 4,000 rows, less than 4,000 rows. So it's not really important how many columns it has, because it's relatively small anyways. On the other hand, we have the transaction stored in the fact table. There we have all the movements, everything which is happening in our business and organization is stored in the fact table. Everything we can measure is stored there. So typically we do not show single lines of the fact table, but we're aiming for aggregations. I want to see all the sales for one product or for one product category for a whole year. So we're aggregating there. And those tables compared to the dimensions are relatively big, depending on your business. It could be hundreds of thousands, millions, billions, whatever. Those tables in our model are always on the many sides. So I filter a year or a product in the dimension, and this filter is then applied to potentially many rows in my fact table, because potentially I have several transactions per year, per product, per employee, per customer, per region. And the fact table usually only have numeric columns. So one type of columns are the key columns. So the foreign key, the keys, the identifiers referring back to the dimension. So I have a key for the date, I have a key for the customer, I have a key for the territory. That's the one part. I usually do not show them in the model, so I hide them, because my end users, I do not use keys in my reports. And then I have numeric columns. So the sales amount, the cost, different sales in different currencies, whatever you are measuring in your organization. So this looks like that. The star schema looks like that. We have the fact table in the middle, fact result sales large. And to be honest, this is a really bad naming. So please do not replicate this in the production environment, because those names should be end user friendly. So this should be the reseller sales or the sales table in the middle. And you should omit this fact and the large at the end. And we should not have camel case or Pascal case here. So it should be reseller blank sales. That would be a good naming. And then surrounded, the fact table is then surrounded by our dimension tables. I only use this naming to make it visible for you as educational purposes, that you see this is a fact table, these are dimensions. And really, we have a dimension for the sales territory, and this is on the one side, and the filter is propagated to the sales table, which is on the many side. The same is true for the dim date and the dim product table. And this is called a star schema. And as in many cases, you need a little bit of imagination, a little bit of fantasy to see like look like a star. This could be a 3-pointed star. So the dim date, dim product, dim territory are the pointy ends of the star, and the fact table stays in the center of the star. I know this is a little bit hard to see, but this is what we're calling a star schema. We could also model this as a snowflake schema. That would mean that we have a little bit of normalization reintroduced, so that not all of the product attributions are in the dim product table, but the product table would then refer to the subcategory, and the subcategory table would then refer to the product category table. You usually should avoid this as much as possible. So the way we avoid this is using, for example, a view or using Power Query to access the product subcategory attributes and add it directly to the dim product table, because then the model is easier to see, because you have less tables there, and it's faster because Normalization also means that the model is more complex, so people have to remember, is this attribute I'm looking for in the product, in the subcategory, in the category table? And a filter propagation is also more complex for the system. So if I select a category, if I want to filter a group on the category, Power BI has then to filter the subcategory table, finding all the products, then filtering the products, and then first we can filter the sales. So this is more complex for us to understand, and it's also slower. So you should avoid the Snowflake schema and always aim for the star schema. If you want to compare those, the Snowflake schema has more tables, and as it has more tables, it takes longer to load. If you refresh the model, it will take longer to load. It will make filtering slower because the filter have to propagate through several tables before it ends up in the fact table, and the filter pane on the right is less intuitive because we have several folders in our filter pane where we can find attributes of the product table. And if you want to create hierarchies for your end users to make their life easier, then it's not possible over different tables. You have to load everything in one single table because we can only build hierarchies upon attributes within one single table. If you want to look on the numbers, what's happening if we have different approaches? So for the single table approach, of course, we only have a single table. This is really easy to understand. And I see sometimes people building stuff like that in one single table. You should not do that. You should aim for the star schema, where we have 4 tables. It was the fact table in the middle, and then we had the territory, the dim date, and the product table. And in the Snowflake schema, we had 6 tables because the product table was then split up into the subcategory, the category table. The size was a kind of surprise for me when I tried this. I mean, this is a small example, 80 million rows in the fact table, and it's the very same data. So it's the same data, only modeled it differently. If I put everything into the single table approach, even with the Vertipack engine, I don't know if you heard about that, but like Power BI is compressing everything really, really good. But still, it means that we end up with a model which is almost 3 times as big compared to the star schema and Snowflake schema. And if it's bigger, of course, it will be slower because open up the Power BI file, it will be slower to load everything into memory. Finding things, of course, we have then to scan more bytes of data, so the performance of your model will be slower. So it's not a good idea to have the single table approach. Aim for the star schema or Snowflake schema. In this example, the size for star and Snowflake is the same because the product category, I think, is only 4 tables, and the subcategory, I can't remember, is it maybe, I don't know, is it 40 rows or something like that? So it's not, doesn't make any big difference. But replicating every attribute on the fact table, and that's what the single table approach is. I have the fact table and dimension is the same thing. So I'm replicating everything on the fact table, and that's why the model is bigger. Yeah, relationship takes a little bit of space. So for this, if you have a single table, we don't have any relationship, so there's no bytes occupied by the relationship, and it's rather small in this example. So we're talking about kilobytes. It's not gigabytes or terabytes. It's kilobytes. So it's like half a megabyte, not even a megabyte of size. It doesn't really count here. And how do you turn your single table into a star schema? This is with Power Query. If you're not in the happy situation that you can access a data warehouse where somebody already thought about the modeling approach and provide you with a star schema, then you can build this on your own in Power Query. So Power Query is used to filter your data, to change the names if it's really necessary, depending on the data source, and also like select the data types and everything. You can flatten your dimension with Power Query, and you should do that, and you should not flatten your facts. So the fact table should be like they are delivered, and for the dimensions, you should flatten them. That means for the product table, I already load the subcategory attributes and the category attributes, the product category attributes, into the product table. That's what I mean with flatten your dimensions. So we end up with a nice and crisp star schema. Any questions so far to the star schema? This is really important.
No questions, no.
Okay. Unless, again, unmute yourself. The most important dimension I see is the date dimension, because most data I see so far is related in some cases are related to, in some way related to our dates. We want to compare how did we perform this year compared to last year. Or how was this week compared to the last week? Or how is the performance on Mondays or on weekends? So this is really important for many dimensions. So it's really important to take care of the data dimension. And we need a dedicated data dimension for two reasons. On one, it's for convenience, because if I do not have a data dimension, people have on one hand on the reports always have to like write text queries to show only the year of the date, or to show only the month of the date, or to filter on stuff like that on the one hand. And it's also necessary for time intelligence. So time intelligence is only a fancy word for doing comparisons over time. So if I want to select August of 2020, I want to see what was the performance or the sales in July 2020. So with the previous month, or with the same month in the previous year, or having the year-to-date numbers. So if I watch the August numbers, I do not want to see the August numbers themselves, but I want to add them up like January plus February and so on until August. And then I want to compare this maybe with the previous year. This is covered by this fancy term, time intelligence. And if you want to do time intelligence in Power BI, you have to use DAX. And DAX forces you to have a dedicated data dimension, which has one single entry for every day for the whole calendar year. So it's not enough to have like only the dates from January to I'm on vacation, so I can't remember what the day is today. It's 18th of August. It's not enough to have like every day from January to August. No, we have to have from January, 1st of January to end of December. And if you have several years, we have to have all the dates, all the calendar days for all those years available in the data dimension. This is really important. If you do not have that, you could end up with wrong time intelligence calculations. And this is really, really bad, because there could be cases where it's not very obvious that the number is wrong, because there's just some days are missing in the calculation, and then you report the wrong numbers, and maybe nobody discovers this for a time. This would be the worst case, I would say. Because this is so important, as I told you at the very first slide, Power BI is an end-user tool. They want to make it really easy for you to use. If you do not have a dedicated data dimension, Power BI will create one for you automatically. And again, it's a good idea, it's a good intent, but I would ask you, please turn this feature off and come up with your own data dimension. There are several reasons. One is, as we will see in the following slides, is that we'll see this in the following slides, why this is like having a little bit of cliffhanger from one side to the other one. And to create a data dimension is rather easy. We have this DAX functionality, Calendar Auto, which will create a table with all the dates from January 1st to December 31st for all the years in your data model. So it will look up all the date columns and find the oldest one and the newest one, and then we'll create the calendar for you. Or, of course, that's what I try to do. If I build a data warehouse, of course, I will have a dedicated data dimension, the data warehouse, having all the dates and also all the attributes there. Because Calendar Auto will only give you a list of dates, and then you have to come up with the idea of what attributes you need, like the year, the month name in English and other languages, the weekday, and also and so forth. And for dates, this is very typical that dates can have different roles. So like we have in our example, which we'll see, there's in the fact table, we have not only one date, we have the order date, but we also the due date and the ship date. So we have 3 dates there. And the question is, how can we model this? And there's 2 different approaches, either role-playing or with mappable tables. We'll see this in the demo as well. If you have a date dimension, please remember to mark this date dimension as a date table. So I'm thinking, I'm really, really 35 minutes, so I will jump over this demo maybe. So there's a demo, and I will provide you with a file where you can play around. And there's only certain occasions where you really have to mark your table as a date table. In other occasions, you could omit this, but the short way is, if you take your date table and mark the column of date type date in this table, this does not any harm. And in some cases, it's necessary. Otherwise, you would end up with wrong time intelligence calculations. And how do you do this? You're going to your date table and then press mark as date table with the check mark. And then this dialog will come up, and then you just select the column of this date table, which is of data type date. You should do this. Shall we go? And I forgot to close this anyways, so maybe I will jump over there to the next demo. The next important thing is the auto date time. Again, service is the idea. So they try to make it convenient for everybody, but it's not always a good idea to have this. One argument is that for this automatically created date timetable, it will create one date table for every single date column you have in your data model. So there might be some dates like you have in your product dimension. You might have a start date and end date when the product was started to be sold and not to be sold anymore. Or you have like a slowly changing dimension model where you have like valid from, valid through, and you didn't delete this when you loaded it into Power BI. Then you have those date tables, date columns there, and for every single date column, Power BI will create a dedicated date table for you. This is the one thing. So the model can be huge in size. So we see like we have 1, 2, 3, 4, 5, 6 date columns, obviously, in my model. And so Power BI came up with 6 date tables there. And those date tables are hidden. So you do not see them in the fields list. You have to open up a tool like Vertipack Analyzer, or you can open it up with Tabular Editor or DAX Editor. Then you would see those tables there. And they can have certain sizes. And if I do not want to have any date capabilities on those columns, I cannot turn this off for single columns. I can only turn it off for all the model, and that's what I would recommend. Because the second thing is this date table consists of year, month, year, quarter, month, and day. It's 4 columns, and you cannot change that. So if you decide I do not want to have the quarter, you cannot delete this from this auto date time dimensions. It's always there. If you think I want to have like the weekday in English added to my date table, it's not possible. We cannot change the appearance of this auto date time. So we are locked in. This only makes sure that we get a little bit like a simple hierarchy on the date column for one, and for the second, that our time intelligence functions work. That's the only goal. It's not that you get a really good date dimension out of that. So my recommendation is to create one for you, one dedicated, and to turn this feature off. So in the options of Power BI, we have 2 situations. We have one for the current file we can just turn off, and you can also turn this off in the global settings. So every time a new file is opened, that this auto date time is also automatically turned off, because you should have your very own date dimension. I have to close. Where is this? Did it open up something? It not really open up something. Okay. Background. There's the relationship. I think I should have closed this one. Don't save some. So the date can be role playing. That's one situation. So what we have here is that I have a very simple model here. We have one fact table. That's the sales table. It's with good naming, at least for the table names. And then I have still this camel case or Pascal case in here with the order date. And there's one relationship from the date table to the order date table. And we see that this is yellow because it's marked. So we can see that the date is filtering the order date table, the order date column. And we also have one with dashed. So this is only points. This is only a dashed line. This is not a straight line. Also going one to many. And I can tell you it's about the ship date. So we have 2 different relationships from the date table. One going filtering the order date, the other one filtering the ship date. This is good enough because now we can have like role-playing dimensions. So in some cases, the date plays the role of order date. In other cases, I can turn this on that the date plays the role of the ship date, and I can then select the year of the ship date or group by the ship date. How is this done? I hope this is opened up in the background.
Markus,
question.
There's one question. Yeah. What's the effect on an existing complex model, so possibly multiple dates, if the date dimension was not marked as a date table and we turn it on afterwards?
No, if you turn it on, there's no effect. So it only can be an improvement. So turning this on is forced. So let's state this. So you have to explicitly mark the date table if you have a date dimension, and the key in the date dimension is not of data type date, but of a different data type, for example, integer. If this is the case, then you have to go in there and mark the date table as a date table and tell Power BI, because the key is an integer, but which of the columns is your date of data type date. This is mandatory. If you do not do this, then you end up with wrong time intelligence calculations. So they end up with weird numbers or not calculating anything. Maybe if there's time at the end, I will show you the effect. If your date table has as the key of data type date, then you don't have to set this. But I think it's rather complicated to remember in which cases do I have to set it or not. So my recommendation is to set it every time, because even when your date dimension has the key of a data type date, it does not any harm to set this attribute. Yep. But it does do harm if you do not set this in certain cases, namely when the data type is not, the key is not of data type date. Is the question answered with that?
Yeah, I assume so, but yeah. All right. Okay. Yep, it's answered. Thank you.
Yep. So my recommendation is always set this. It doesn't any harm, but it could be harmful if you do not set it. And I think this is the shortcut everybody can remember, and then you don't have to think about it. Always set it, and then you're good in all the cases. So now I have this mark. I need this later. And where is my? Yeah, let's go there, as we already have been there. So the effect is for time intelligence functions. So let's go back to this, what the question was referring to, the Markus date table. So I have in this one file, I have two different versions of this model. So once I have a version where I have the sales table and the date table, and they're connecting and they're filtered by the date column, and the date column is of data type date. And if I do this, and did mark or did not mark the sales table, everything is fine. So I can filter something in the date, it is filtered there. And the important thing is the time intelligence thing. So I have one measure here. I created the measure up there, but I replicated the code so we can easily read this. So this is the sales amount year to date. And I do this with the calculate function. The calculate function can do several things. And one thing is that I pass in an expression, a measure, and then pass in a filter. So this measure is now not calculated by the already available filter context, but I'm manipulating the filter context, so setting, I do not want to see the sales amount for the specific date, but I want to see it for all the dates since start of the year. And this is what we can see here. So for the sales amount, we had 48,000 in October, and we didn't have any sales in November and December. And this year to date is then calculated as the sales of the year to date value of the previous month. There is nothing plus the actual month. This is 48,000. In November, we also see 48,000 because year to date means take the year to date value of the previous month plus the value of the current month, which is empty. So I end up with 48,000. And we can see this is really calculated like that because at the end, we do not see 3 times 48,000, but we still see 48,000. So the year-to-date value is also like the year-to-date value of those columns. And if I do the same for a model where I use the date key, and then this time I have a date key, which is not of data type date. So it's of integer. And this is best practice in data warehouses to have always keys in integers, either integers or big integers in SQL Server. So in data warehouses, we try to avoid having anything else than an integer key. And then you end up with having the filter not on the date column of data type date, but on an integer column. And this is no problem at all for many cases. So if I'm going there for the date key, I still can select a date in my date table, and it will filter down my my things I'm seeing in the report. This is working. So if I like, what is this? If I'm selecting this the 2nd of 2019, then we'll see that this date is then changing. So this is working. The only effect we are having if I'm having the same calculation, they calculate with the sales amount and the dates year to date on this model, because now the year to date value is not working. We don't see any values for November and December. And the reason is because I didn't mark the date table as a date table. And how can we change this? So we only get there for the date key. I think I have it here, date table, mark as date table, and then I get this drop list to select the column. And I only have one column of data type date. So this is the only selection I can do here. So select this, and then I press OK, and that's it. And now if this is finished working on it, also this is working. So this is the long story to the short version of always mark your date table. Oh, let's close this. And then automatically the next demo should be open for the role-playing dimension. So dates typically have different roles. As like in my model, I have an order date and a ship date in my sales, and I want to filter on both of them. And one way is to having this role-playing dimension. So I only have one dimension, and this plays a different role. How can I do this? As I previously stated, you either have a simple model and more complex DAX. In this case, we have a simple model because we only have one date table, and this is playing two different roles. So we have a little bit more complex DAX code to solve this issue, to either filter on the order date or on the ship date. I think this is opening. Is it opening somewhere? Where do I get my Power BI file? I think I closed the wrong one, the other one. Budget is there. Role playing, yeah, should be opened. Where is it? Ah, here, role playing. Here it is. So what I've got here is one version is that I have like this role-playing dimension. So we have one filter from the date dimension to the sales dimension or the order date, and then I have another one on the ship date. And the second one is like a dashed line. So if I click there, the reason for the dashed line is that this relationship is not active. This is an inactive relationship. Why should I create an inactive relationship? So just make this active, because I created it because I want to use it. I want to have this active. But if I try this, we get this error message. It's not only a warning, but I cannot click on OK, so it's an error message. You can't create a direct active relationship between sales and date, because an active set of indirect relationships already exists between these tables. That means I only have a relationship between date and sales. And if somebody filters the date dimension, and I have two active relationships, Power BI do not know, should it filter on the order date, or should it filter on the ship date, or even both? And all those solutions would be wrong, because if it's filtering on both, that would mean I would only see sales which are sold, ordered, and shipped on the same day. And this may be not the usual thing. So I would end up with two small numbers in my report. So how can I solve this? We solve this in DAX. So we have to reach out to DAX, and we have this here, the date filter. So I have like two different date tables, date columns. So there's the order date and the ship date. And if I filter anything here, so if I start this filter on October 2nd, then we will see this filter is working, and it's only filtering the order date. It's not filtering the ship date. So if I start this on and say that I want to have this only to the 3rd of October, this is like the proof. It's only filtering the order date. It's not filtering the ship date, because ship dates are in November, so they should be gone. I can have the order and the ship date by using DAX. So again, we met this guy calculate. Calculate is this powerful DAX function. And in this case, I do not have a measure here. I have an expression here. It states I want to have the sum of the sales quantity, but for the sake of this calculation, please manipulate the filter context. Do not show it like it is would be filtered normally. Please activate, please use a certain relationship. I have a relationship in my model, which is between the ship date and the date column. And for the sake of the calculation of this measure called ship quantity, I want you to use the ship date. The ship date should be filtered by the date. So this is what we're seeing down there. So we see the ship quantity, and the ship quantity is this measure. This is filtered by the date table, but it's filtered on the ship date. So we see the 1st of November, we had 13 shipped. On 2nd of November, we had 5 items shipped. Usually, I also create one for the default, for the active relationship, also with the same thing, except that I state the use relationship, the order date. It should be filtered on the order date. Because otherwise it would be confusing. If I use the quantity, it's filtered by order, and if I use the ship quantity, then it's filtered by the ship date. Usually I create 2 different measures for these things, and it's always clear, no matter which relationship is the active relationship in the model. So, but if somebody changes the activation checkbox, then I do not want to change anything in my report. So we have a simple model, only one table, 2 different relationships. One is active, one is inactive, and I can activate the relationship within DAX through use relationship. That's the one possibility. The second possibility is to have a dedicated table for each row. So I could have 2 different tables, an order date table and a ship date table, and the order date table is filtering in one-to-many with a single direction to the sales table on the order date, and I could have a second table, ship date, on my ship date. And this means that now my model is a little bit more complex. Instead of having only one table, I have 2 tables. So this is more complex. But I do not have any inactive relationships. I only have active relationships. So this is maybe better. And of course, we have really 2 different tables there. So the storage is bigger now. We're using more space in our Power BI file. But as stated previously, the date table has 400 rows per year. So this is maybe not a big deal. So we can afford, usually we can afford having this dimension duplicated. Any question?
Hey Markus, just one question. In case of multiple date tables physically made inside a model, do we have to mark all of them as a dates table?
That's a good question. I didn't think about it. Yes, all of them have to be. Do they? I have to look this up, to be honestly, because I think I remember that there's only one table can be marked as the date table, but I'm not sure yet. I will check this in case I'm bored with Alexander's session. Then I will check this during his session, or if I'm fast enough, I will check this in the break, and we'll immediately come back with the answer for that. That's a really good question.
Yeah. All right.
So for the multiple tables, we are having, this is looking like, where is my Power BI? So the Power BI, where is it gone? The windows look a little bit, yeah, here it is, date multiple, here it is. So this is the other approach where I have 2 different tables. So I have a ship date and order date, 2 tables. One is filtering the date, is filtering the order date, and the other one, the date is filtering the ship date. Again, this is not very good naming, because a better naming would be to having you should prefix like the date table, the date column should be the order date and the order month and the order year, and also here the ship date, ship month, ship year. So there's a little bit of work to do for a good model here, because otherwise it's not clear if you have the year in your report, which of the years. Is it the ship year or is it the order year? So please remember to do better namings than I have in my examples here. For the reports, we can now allow to have 2 different slices. So one slicer can then filtering on the order date. So I changed this to 2nd of October. Then we get the order date filter by that. And the other filter could be on like 3rd of November, not 13th, but 3rd of November. So never type in a demo. 3rd of November, so it's filtering the ship date then. And with this approach, we can also allow for having a report like that, to having like the order dates in the rows and the ship dates in the columns, so I can see on which date something was shipped and on which day it was ordered. So let's go back here to this, so we can really see that things that were ordered on the 1st of October were shipped on 1st of November and not the other days. And this is also true for the other ones. If you need a report like that, do not do role-playing dimensions, but use the duplicated dimension approach. And in this case, as the model is slightly more complex, 2 different tables, we do not have to use any complicated DAX. I just use the measure as it is. I use the sales amount measure in my the quantity. Sorry for that. The quantity column or quantity measure. I do not have to do anything with user relationship and like that. Back to slides. How much time do we have back for my use case? Again, I had this effect yesterday. I do not see the time here, but I have it on my phone. So 2 minutes for the use case. So I will do a quick thing here. So two use cases, and let's do a quick thing about the budget. So I call it budget. But the idea behind it is that having a situation where you have fact tables of different granularity. So usually you do not do the budget, for example, on the same granularity as you do your as you have your facts. So for example, your facts are like multiple things per day, and you have it on, of course, your facts on the product level and other dimensions. But usually the budget is only done maybe only once per month. So we have a budget for the whole month, or we have a budget only for the product category and not for each product. So this is the idea of this use case. And how can we model this? We have 3 approaches, and I will show you 2 of them. So the many-to-many relationship, as I referred to this in the very beginning, and the bridge table. And the bridge table is the better approach. The many-to-many shows some problems, as we will see here in this example. So currently what I have here is I have the sales. Let's go to the model first. So I have the sales table here. So one fact is the sales table, and it's filtered by date, and it is filtered by the product table. I have the fact table now here, and I have the second fact table, the budget I have here. For the sake of simplicity, I made the budget on single date level. So the only problem I'm facing here is that the budget is on product group level and not on product level. And with that, I have the problem that if I select a product, it's not filtering the budget table. So there's no filter in here, and we end up with the report like that. So for October, group 1, we have a sales amount of 33,000. So this is group 1. This is 100, 110 for October, 100, 110. This is 3 plus 20 plus 10. Those 3 values make this 33,000, and the 15,000 is the group 2, also in October. So group 2 is product ID 120. This is this product here. So this is working. For the budget, we get these weird numbers of 27,000 every time. So this is repeating. This should be an alert sign for you. If numbers are repeating, usually there's something wrong. And the last sign is that like it sums not up. 2 times 27,000 is not 60,000. So there's something wrong in here. And the reason is that the product group 1, group 2 is not filtering the budget. What we are seeing here is that it's only the date dimension is filtering the budget. So this 27,000 are the numbers for October. In October we have 20 and 7, so it's 27,000. That's what's happening in repeating here, because the group is coming from the product table, and the product table is not filtering the budget table. That's why we're ending up with that. Why do we have the 60,000 at the end? Because here we don't have any filters, neither on the group, the product, nor on the month or date dimension. So we get the 20 plus the 7 plus the 25 plus the 8,000, and this is 60,000. And one approach could be, like we heard at the beginning, now with Power BI, we can go there and take the product group and just move it there to the product group. So easy it is to create a relationship. And what we get here is that we see there's the group in the budget, there's the group in the product. This makes sense. Yes, makes sense to like have a relationship on that. And it's suggesting it's a many-to-many cardinality, because we have group 2 is repeating here and group 1 is repeating here. So this is a many-to-many relationship, not in the sense of database logic, what we try to normalize. This is a many-to-many, so I don't know why Microsoft reused the same naming, because what that means is that we have many elements on there and many elements there. So there's not one single table of those two tables. We have a distinct list of the product groups. So there's many repeating values here and there's repeating values here. This is what this many-to-many means. And it's warning me, yeah, you should be aware of what you're doing. And, yeah, but the usual end user will just click, okay, yeah, just try this out. So we're creating this. I don't care about warnings, because of course I know what I'm doing. And when we're going back to our report, now this report is working. So we see like group 1, group 2, and the budget is right there, 20 and 25,000. Hooray! How cool is that? Many-to-many solved our problem. But we have still one problem. There's a budget on group 3, and as group 3 is not part of the product table, we don't see this budget. The budget is disappearing. So we don't see the thing. And you can replicate a similar thing with read-s. I'm not doing this because I'm running out of time, but I want you to know how to solve this accordingly. And the right way of doing this would have this one. So what I have here is that if I have my list here, I want to see group 1, group 2, and group 3 to the accordingly months and all the values. I want to see all the budget values. I want to see all the sales numbers. And how do you do that? From running out of time, you have to introduce a bridge table. So bridge table is a technical term, which means that I have to have a table in between. So I have not have a many-to-many relationship like many on both ends, but I have a one-to-many and another one-to-many relationship. And this bridge table consists of a distinct list of product group values. Either you have this in your data warehouse, or we can create this bridge table in DAX. So I can also create something in DAX. A table in DAX. What I'm doing here is I'm creating a distinct list of my product groups in the budget table. I get a distinct list of my product groups in my product table. Then I'm unioning those two. But it could be that group 2 is coming is being is a row in budget and product. Then I would end up with 2 rows of product group. That's why I'm doing a distinct again over the union, and then I end up with a distinct list of all my product groups. And this is what I can then show in my report. And that's how I end with the right way. So the product group in this table is not the product group of my product table, but the product group is the product group of my product group bridge table. And with that said, I'm just slightly over time, I guess. Yeah, this is something we will not see a more complex demo about the data model. The takeaways is, please take care of your models. I hope I could show you some things, some weird side effects if you just depend on the defaults. It's really important to model this right. Stay away from many-to-many, stay away from bidirectional cross filters, prefer the star schema, and you can always exchange the complexity in the model for the complexity in DAX. So sometimes it depends on what you prefer. Sometimes it could be that the model approach is faster, sometimes the DAX approach would be faster if you think performance-wise. There's also links there. I will send up the slide deck and the demo files to Benny right after that. And are there any more questions? Because I'm really running. Because Benny kicks before Benny kicks me out.
There's a few questions.
Yeah.
One, I'm curious to see what your preference on this one is. What's your personal preference? Role-playing dimensions or physical tables in the dimension?
Yeah, I think it's easier for the it's not about my personal preference, because my personal preference, if I would build a model for myself, I would do the role-playing thing, because I'm good enough in DAX to play around with that, and I only have the data table once in the model. But if I build something for Power BI, usually it's not for myself, it's for my customers, for end users, for people who do not think in Power BI, who do not think in databases. They want to have an easy model to build reports on. And there, I would say it's easier to have the double table approach, because they want to have like something about the shipping date, the shipping year, and so on, and they find it then in the model in the field pane. So it's easier for them to do. And if you're in doubt, always ask the end users, what do they prefer? Do they have just one data table where they have to think what kind of measure they're using, so they end up with different filters? or is it easier for them to have actual 2 tables? So when in doubt, always ask the end users who will use the Power BI report.
Yep. All right. Thank you.